Welcome friends, let us go for the next part of discussion, that is amplitude as well as the intensity. Amplitude, the height of crust or depth of trough from the mean position of a wave propagation is said to be its amplitude. This is a wave propagation's one single part, that is wave is taken. This is the mean line. From the mean line position, the minimum distance present between the mean line to the crust. Similarly, the minimum distance present between the mean line to trough. You can take anything that is taken as reference as amplitude. Amplitude is proportional with or related with the intensity. Suppose if combination of waves are occurring, that is said to be interference, addition of waves. In phase waves are going to be interfered in such a way that one wave energy is connected with the other wave, and we will be getting the enhanced energy containing a wave that is represented in the form of single wave. Thus, addition of wave A and wave B are of same, and these are added one with other. Interference occurred. As a result, a single wave is generated. The single wave is having higher energy. Such kind of relation is represented with the maximum amplitude. That is, amplitude of A and B are smaller compared to amplitude of C. Thus, amplitude is measure of the distance present between the mean position of the wave propagation to either crest or trough is said to be the amplitude. Amplitude is related with the intensity. Intensity is once again related with what? Energy. Intensity, generally indicated by I, it is related with the brightness of the light. The more brightness, we feel that it is more intense, and the less brightness, we feel that it is having less intense. A room of more lights is more bright, we feel it is more intense technically. Similarly, the same room of less number of lights, less bright, that we can feel it is of less intense technically. So it is the rate at which the light energy is delivered to unit surface area. Otherwise, energy delivered for unit area for unit time is reference is taken as granted for the definition of the intensity. For unit surface area in unit time, how much of energy is expected from the light source is said to be its intensity. That is, on unit surface area in 1 second time, how much of energy is felt, that is taken as definition and the reference to measure the intensity. Whereas intensity is related with the amplitude, as we discussed in the amplitude definition and amplitude related information. I, intensity is proportional to square of amplitude. As amplitude increases, intensity increases, because amplitude is measure of number of waves. More amplitude, more number of waves. Less amplitude, less number of waves. As number of waves increases, energy is additive property, energy is added, hence the intensity also increases. That is, I is proportional with A square. More amplitude implies more intense, less amplitude implies less intense. Here, brightness, intensity, energy, number of waves and amplitude are interrelated with one another in such a way that, suppose more brightness, the meaning is more intense. Technically, the meaning is more intense. That is, the sensation is more brightness, and the meaning, inner meaning is more number of waves, and another technical meaning is more the amplitude. Similarly, less brightness, the meaning is less intense, less amplitude, less number of waves, less energy, and here more energy, that is less energy, and here it is more energy. Thus, more brightness, more energy, more intense, more number of waves, more amplitude. Similarly, less energy, less brightness, less intense, less number of waves, lesser is the amplitude. Here from a source, light energy is falling on the surface area. This is 1 square centimeter unit surface area. If I take for 1 second time, the energy felt from the source on unit surface area in 1 second time is said to be its intensity. Intensity with respect to source can be known like that. Energy liberated in the form of light from the source within 1 second time is said to be its intensity. Or intensity of the room can be calculated like this. That is, within square centimeter area for 1 second time, energy felt from the source is said to be its intensity. Energy. Electromagnetic radiation is a form of energy. As being visible part of the electromagnetic radiation, generally known as light. Light is a part of electromagnetic radiation. The total electromagnetic radiation is a form of energy. The part of electromagnetic radiation, light, is also a form of energy. Theories related to the electromagnetic radiation and its properties can be explained in the form of wave. Energy is also property. This property of energy of electromagnetic radiation or light are explainable in terms of the measurable properties, that is parameters associated as electromagnetic radiation in the form of wave. So therefore from the wave features, the corresponding energy associated with the electromagnetic radiation can be given by E is proportional with frequency nu, whereas from the Max Planck's quantum theory, this particular relation is standardized by replacing the proportionality constant, by replacing proportionality with the proportionality constant, that is E is equal to h nu, that h is said to be the Max Planck's constant, generally known as Planck's constant. Whereas from yesterday's discussion, we are very clear about nu is equal to what? C by lambda. Whereas C by lambda can be written as C into 1 by lambda. 1 by lambda is known as what? Frequency, that is wave number, that is nu bar. Here h is said to be the Planck's constant. The corresponding value of Planck's constant in CGS system is 6.627 10 power minus 27 erg seconds. Whereas in SI system, its value will becomes equal to 6.627 into 10 power minus 34 joule seconds. This is energy associated with the electromagnetic radiation and energy associated with the visible part of light, visible portion of electromagnetic radiation, generally known as light. Yes, from the formula relations, E is equal to h nu is equal to hc by lambda, hc into 1 by lambda hc mu bar. Whereas energy is proportional with the frequency, energy is proportional with the wave number, energy is proportional with 1 by wavelength, or energy is inversely proportional with the wavelength. As frequency increases, energy increases. As wave number increases, energy increases. As wavelength increases, energy decreases. Measurement of energy. The measurable amount of energy can be small or can be huge. Hence, along with the systematic units for the measurement of energy, like CGS unit as well as the SI unit, other units are also be taken. Those units are generally said to be the derived units. Whereas the systematic CGS and the SI parts offering units for the measurements of energy are CGS system of unit is erg, SI system of unit is joule. Along with this, smaller units are also necessary sometimes and the bigger units are necessary. The smaller unit taken is electron volt. Similarly, the bigger units are calories as well as the kilocalories. That is the order related to the unit, smaller unit and the bigger units relations are electron volt is a smaller, and compared to electron volts, ergs is somewhat bigger. Compared to ergs, joules followed by calories followed by kilocalories is the bigger unit. Whereas here erg and the joules are the systematic units and remaining all are derived units. Collection of some electron volts gives ergs, collection of ergs will gives joules, collection of joules will gives calories, and collection of some number of calories will provide you kilocalories. So kilocalories is bigger, kilocalories is consisting some number of calories, calories are consisting some number of joules, joules are consisting some number of ergs, and ergs are consisting some number of electron volts. This is the smaller unit and this is the bigger unit. Suppose if I take 1 kilocalorie, that is consisting of 1000 calories, whereas every calorie is consisting of 4.2 joules and every joule is consisting of 10 power 7 ergs, whereas every erg is consisting of 0.624 into 10 power 12 electron volts. So therefore 1 kilocalorie will becomes equal to 1000 into 4.2 into 10 power 7 into 0.624 into 10 power 12 electron volts. That is measuring of energy from the lower measuring unit to the higher measuring unit. That is electron volts, conversion of electron volts to ergs, ergs to joules to calories and the kilocalories. 1 electron volt is equal to, electron volt is a subpart of ergs, so therefore it will be lesser than 1 quantity, 10 powers minus 1.60 to 10 power minus 12 ergs. Whereas this one, if it is expressed in terms of joules, every erg is 10 power 7 portions of joule, so therefore this is 1.60 to 10 power minus 12 into 10 power minus 7, which will becomes equal to 10 power minus 19. Whereas this one, in terms of calories, every 4.2 of joules will becomes equal to 1 calorie, so therefore 1 by 4.2 into 1.60 to 10 power minus 19 calories in kilocalories. If I divide this one by 1000, 10 power minus 19 is converted to 10 power minus 22. Whereas 1 by 4.2 is 0.238, 0.238 into 1.602 will becomes equal to 0.381 into 10 power minus 19 calories. Like this, the lower measuring units of energy and the higher measuring units of energy are interrelated with this relational logic. The visible part of electromagnetic radiation is having its corresponding wavelength in the range of 3600 to 7200 Armstrong units. Whereas it is a small part of electromagnetic radiation acting as energy source. Whereas now we are going to interrelate the formulas with the calculations like wavelength, wave number, frequency, energy and all the things. Whereas within the visible range of 3600 Armstrong units to 7200 Armstrong units, in the mid, all varieties of wavelengths are present. Now you are asked to calculate for the 4000 Armstrong units related wave number, frequency as well as energy in all varieties of units. See, wave number can be given by mu bar is equal to 1 by lambda. Here 1 by lambda value is 4000 Armstrong units. Generally, wave number expressed in terms of centimeter inverse, though meter inverse is also there, but wave is of very small, measured in centimeters, the least system for the systematic part, that is CGS system, hence it is expressed in terms of CGS system of units 1 by centimeter, and this is centimeter inverse. 1 by 4000 Armstrong units, whereas 1 Armstrong unit is consisting of 10 power minus 8 centimeters. So therefore this is 1 by 4000 into 10 power minus 8 centimeters, which will becomes equal to 10 power 8 by 4000, 10 power 5 by 4, which will becomes equal to 2.5 into 10 power 4 centimeter inverse. The same way, if I express in terms of wave numbers, the number will becomes equal to 2.5 into 10 power 4 centimeter inverse. Similarly, calculation of frequency can be given by C by lambda. Here, frequency doesn't have a measuring different units in case of CGS and the SI system, because it is number of waves for the second time. It is nowhere related with the length and all the things. Hence, in CGS system or in SI system, frequency is frequency, there is no modifications. Frequency C by lambda. C is velocity of light, lambda is wavelength. If I take the same units, then per second the number of waves is said to be the frequency. In this case, wavelength, that is 4000 Armstrong units, and the velocity of light, all electromagnetic radiations travel with the same velocity, that is 3 into 10 power 10 centimeters per second, because here also I am modifying the Armstrong units into the centimeters. Now on calculation, this is 3 by 4 into 10 powers of 10, and this minus 10 comes to the numerator, becomes plus 8, plus 8, minus 8 becomes plus 8, and this is plus 3 in denominator is converted as minus 3 in the numerator. 18 minus 3, that will becomes equal to 15.75 into 10 power 15 hertz. This is the frequency. The same wavelength in terms of wave number, this is 2.5 into 10 power 4, whereas in terms of frequency that will becomes equal to 0.75 into 10 power 15 hertz, otherwise cycles per second. Whereas energy associated with the 4000 Armstrong units, energy E is equal to h nu in ground parameters of the wave, that is hc by lambda. H is Planck's constant. Here I am calculating in terms of CGS system Hertz, 6.627 into 10 power minus 27, and c is velocity of light, 3 into 10 power 10 centimeters per second divided by lambda, 4000 Armstrong units, 4000 into 10 power minus 8 centimeters. Now on calculations, this will be for 6.627 into 3 divided by 4. All tens if I write in the form of numerator, 10 power minus 27, 10 power plus 10. This is 10 power plus 8 in the numerator, 10 power minus 3 in the numerator. Whole will becomes equal to 10 power minus 12, and this calculations leads to 0.75 into 6.627, and whose multiplication product is 4.9 into 10 power minus 12x. Whereas 10 power minus 12 appears to be very small quantity, hence to express this one which is the minimum measurable quantity, minimum rememberable quantity, here I want to express this one in the lesser units of measurement, that is electron volts. We know the relation between the ergs as well as the electron volts. Erg is greater, electron volt is smaller, so therefore electron volt, some number of electron volts will becomes equal to erg. So therefore 1 erg is equal to 0.624 into 10 power 12 electron volts. On multiplication, 10 power plus 12, 10 power minus 12 cancels. 5 into 0.624, that is 3.05 into 10 power 1, 10 power 0, nothing but what? 3.05 electron volts. That is the electromagnetic radiation of visible part, which is known as visible part of electromagnetic radiation, generally known as light. Light is having energy range in terms of what? Electron volts, 3 electron volts for the 4000 Armstrong units. Suppose if I take 4000, 3600, then it is having somewhat greater. Whereas if I take wavelength is somewhat greater, then energy should decrease. It will be lesser than 3.057 electron volts. Thus, calculations of energy, calculations of interconversions of all other parameters of wavelength to other parameters, wave numbers to other parameters, similarly frequency to other parameters, energy to all other parameters are interrelated and connected with one another. All relations of the wave parameters of electromagnetic radiation, energy E is equal to h nu is equal to hc by lambda, whereas hc by lambda is equal to hc into 1 by lambda, which is equal to hc nu bar. Whereas mu is equal to c by lambda, mu bar is equal to what? 1 by lambda. The tabular form of all interrelations, that is lambda in terms of lambda, mu bar, nu as well as the energy, wave number, that is nu bar in terms of wavelength, wave number, frequency as well as energy, and frequency in terms of wavelength, wave number, frequency as well as energy, energy in terms of wavelength, wave number, frequency as well as in terms of energy. Suppose if I go for the wavelength, wavelength is equal to wavelength. Wavelength in terms of wave number, that is reciprocal of wave number, is equal to wavelength. The definition says the same. Similarly, wavelength in terms of frequency, frequency that is c by lambda. C by lambda will become c by nu. C by nu will becomes equal to lambda because nu is equal to c by lambda. Here nu is equal to c by lambda, lambda will becomes equal to c by nu. Similarly, the wavelength in terms of energy can be given by hc by E is equal to wavelength because E is equal to h nu, that is E is equal to hc by lambda, lambda will becomes equal to hc by E. In the same way, wave number in terms of all parameters, frequency in terms of all parameters, energy in terms of all parameters is like this. This table is important to try to remember the things. And the corresponding units of lambda, centimeter or the meter, whereas wave number, centimeter inverse or the meter inverse, whereas frequency always the same, that is cycles per second, which is also known as hertz, whereas energy in CGS system X and in SI system it is joules. There is one new constant term, that is Planck's constant, h is equal to 6.627 10 power minus 27 erg second, whereas that will becomes equal to 6.627 10 power minus 34 joule seconds. Whereas c is velocity of light, that is 3 into 10 power 10 centimeters per second, else that is 3 into 10 power 8 meters per second. Calculate the wavelength in nanometers as well as Armstrong units and the wave number in centimeter inverse followed by frequency hertz cycles per second of the following energies of the electromagnetic radiation. Question number 1, having 13.6 electron volts, having 13.6 by 4 that is 3.4 electron volts, 13.6 by 9 that is 1.5 electron volts, 13.6 by 16 that is 0.85 electron volts, 13.6 by 25 that is 0.544 electron volts. And another question for you is calculate the wavelength, wave number, frequency of the electromagnetic radiation having energy as 13.6 into 3 by 4 that is 0.75 times 10.2 electron volts, 5 by 36 into 13.6 that is 1.88 electron volts, and 7 by 144 into 13.6 that is 0.661 electron volts, 0.306 electron volts and 0.166 electron volts related wavelength in Armstrong units as well as nanometer, wave number as well as frequency. You calculate these of all things. Light is a part of electromagnetic radiation. Electromagnetic radiation is so broad based on the available average energy levels. It is segregated into different parts, whereas here it is classified as from higher energy to lower energy in an order, if I write, that is said to be the electromagnetic spectrum. Spectrum consisting of different varieties of energy levels like cosmic, gamma rays, X-rays, UV rays, visible part of electromagnetic radiation which we generally call it as light, followed by infrared radiation, microwave radiation, and the least available energy is the radio waves. Whereas the energy decreases from top to bottom. Energy decreases implies frequency decreases, wave number decreases, whereas wavelength increases. Whereas different varieties of quantities are there from minimum to maximum. To represent that, let us go for the table. Suppose if it is expressed in powers of 10, 10 power of 24 is said to be iota and it is represented with the capital Y. Whereas 10 power 21 is represented as zeta and it is indicated as capital Z. 10 power 18 exa and it is indicated as capital E. Similarly 10 power 15 as beta indicated as capital P, and 10 power 12 as tera indicated as capital T, 10 power 9 as giga indicated as capital G, 10 power 6 as mega indicated as capital M, and kilo indicated as small k, whereas hecto 10 power 2 indicated as small h, and deca 10 power 1 is indicated as D followed by A. 10 power minus 1 is said to be deci indicated as small d, and 10 power minus 2 as centi indicated as C, and 10 power minus 3 as milli indicated as small m, 10 power minus 6 as micro indicated with symbol mu, 10 power minus 9 as nano indicated with small n, 10 power minus 12 as pico indicated with small p, and 10 power minus 15 as femto indicated with small f, 10 power minus 18 as atto and indicated as A, 10 power minus 21 is zeta indicated with the small z, and 10 power minus 24 as acto indicated as small y. In the same way here, the frequencies, if you observe, frequencies goes on decreasing and it is generally indicated with the hertz. The radio waves range in between 3 hertz to 3 gigahertz, whereas microwave range in between 3 gigahertz to 300 gigahertz. Similarly here 300 gigahertz to 300 terahertz, and this is 416 terahertz to 833 terahertz. This is up to 30 picohertz. Now here it is E hertz to 30 E hertz to 300 E hertz. Like that, frequency range is present for every particular variety of the electromagnetic radiation. The corresponding wavelength, the cosmic rays wavelength ranges in between 1 picometers to 10 picometers, whereas gamma rays 10 picometers to 100 picometers, X-rays 100 picometers to 10 nanometers, whereas visible part 10 nanometers to 360 nanometers, and visible part is 300 to 720 nanometers. UV is 10 nanometers to 300 nanometers, whereas the IR radiation lies in between 720 to 1 micrometer, whereas this microwave radiation lies in between 1 centimeters to 1 decimeter, and radio waves lies in between 1 decimeter to 100 megameters. Like this, the wavelength range is also present. Corresponding energies, if you look at, gamma rays are associated with highest energy, that is 1.24. Capital M stands for mega, 1.24 into 10 power 6 electron volts, whereas visible portion of electromagnetic radiation is small, that lies within the range of 3.4 electron volts to 1.7 electron volts in between, whereas still IR is having lower energies. UV, X-ray, gamma, cosmic rays are associated with the highest amounts of energies. This particular classification is said to be the broad spectrum of electromagnetic radiation. One particular logical remembrance is, here the UV portion, the visible part of electromagnetic radiation, is associated with higher energy UV radiation and lower energy infrared radiation. And the visible part of electromagnetic radiation is consisting the high energy VIBGR, that is violet color, indigo color, blue color, VIBG, green color, yellow color, orange color, and the red color ranges from here to here. That is VIBGR consisting of V, I, B, G, Y, O, R. This is the portion that is near to the UV, violet color is present, and nearer to the orange, nearer to the red color, the IR radiation frequencies, wavelengths, and the energies will match. Like this, the broad classification of segregation of all possible varieties in order of either increasing or decreasing of frequency, wavelength, or wave number or energy is said to be the broad spectrum of electromagnetic radiation. So if you consider this particular red color portion is merged with the IR portion of the electromagnetic radiation, the ranges matches like this. These two will belongs to radio wave, highest and the lowest. These two will belongs to microwave, highest and the lowest. These two will belongs to IR of highest and lowest. And this is visible portion of highest to lowest, and these two are UV portions, these are X-rays, these are gamma rays, and these two are the corresponding cosmic rays and corresponding energies, frequencies, wavelengths, etc. of related electromagnetic radiation of broad spectrum are appears to be like this. Within the broad spectrum of electromagnetic radiation, the visible part is associated with the UV radiation as well as the infrared radiation. Whereas it is having near UV radiation connected with the visible, that is violet part of electromagnetic radiation, and the red part is merged with the near infrared radiation. Whereas if I write the broad part of the visible portion, that is violet, indigo, blue, green, yellow, orange, as well as the red in colors, out of these light of 7 colors, the violet color is having highest energy, highest wave number, highest frequency, but lowest wavelength is there out of these light of 7. And in the same way, red is having the lowest energy, lowest frequency, lowest wave number, but highest wavelength is present. This is having lambda max and this is having lambda minimum in the visible part of electromagnetic radiation. Whereas compared to the energies of the visible portion, the UV portions of every particular wave is having higher energy compared to energy of any of the color of the electromagnetic visible part of radiation. Infrared radiation is having lower energy. Energy decreases from top to bottom, higher energy, lower energy. Similarly, compared to this set of visible, UV is having higher energy and infrared is having lower energy. And all things happens in the same regular order. That is, red is having highest wavelength, lambda max, least energy. Similarly, violet is having lambda minimum with highest energy of visible part of electromagnetic radiation.